Everyone, I'm Jeffrey from Shri Venkateswara College of Engineering, and today I'm going to talk about the performance of a computer. The basic idea is a good performance results from achieving a high throughput while keeping the response time low. System that can efficiently process a significant amount of work in a short time is considered to have a good performance. So the equation for performance is throughput by response time. Throughput, this represents the amount of work or data that a system can process in a given time. It is often measured in terms of transactions per second, instructions per second, or data transfer rate. Response time or latency. This is the time taken, which is taken for a system to respond to a request or perform a task, which includes both processing time and waiting time. The execution time or runtime of a program in a computer can be expressed using the following equation. Execution time is equal to construction count into CPI into clock cycle. Here's a breakdown of the terms in equation. Execution time. This is the total time it takes for a program to execute from start to finish. It is usually measured in seconds. Instruction count. This represents the total number of instructions that the program executes. CPI, cycles per instruction. CPI is the average number of clock cycles required to execute one instruction. It reflects the efficiency of the instruction executed in terms of clock cycles. Clock cycle times. This is the duration of one clock cycle, which is determined by the clock speed of the processor. To measure the performance of a computer, you can use combination of benchmarks, monitoring tools, real-world testing. Here's an overview of how you can approach performance measurement. Benchmarking, monitoring tools, application-specific testing, storage performance, network performance, real-world usage, temperature, and power consumption. Benchmarking. Use benchmarking software to access specific components like CPU, GPU, and storage. Examples include Geekbench, Signbench, 3D Mark, and Crystal Disk Mark. Consider comprehensive benchmarking tools like PC Mark provide an overall assessment of a system's performance. Benchmarking. Use benchmarking software to access specific components like CPU, GPU, and storage. Examples include Geekbench, Signbench, 3D Mark, and Crystal Disk Mark. Consider comprehensive benchmark tools like PC Mark that provide an overall assessment of the system's performance. Monitoring tools. Utilize built-in tools like Task Manager or Activity Monitor to monitor real-time CPU usage, memory usage, disk activity, and network activity. Use more advanced monitor tools like SW Monitor or Resource Monitor for detailing insights into resource utilization. Temperature and power consumption. Monitor the system's temperature using tools like HWInfo or Core Temperature. Access power consumption to understand the efficiency of the system. Keep in mind that the performance evaluation should be context-specific. The requirements for a gaming computer, for example, may differ from those of a workstation used for content creation or server handling. Large-scale data processing. Consider your specific use case and the task of a computer needs to perform when assessing its performance. Thank you.